All right. Hey, everybody. We are back in lesson 9.2 of the Tennessee Revealed Geometry, Pythagorean Theorem and its Converse. All right. A squared plus B squared equals C squared. It's what you use when you're looking for the missing side of a right triangle. And I know you've done this before. Here it is again, I guess, the formal lesson on it. All right. So A squared plus B squared equals C squared. That's the Pythagorean Theorem. And all right, so I'm on the page 513 of your consumable workbook. And it looks like we have the Pythagorean triple, which is a set of three numbers there. They can't be zero, that make up A, B, and C of your Pythagorean theorem, A squared, B squared, and C squared. Probably the best known one is the 3, 4, 5 triangle, where you have the right triangle and one leg is 3, the second leg is 4, and the hypotenuse is 5. Well, if you double that, like 3 times 2, you get 6, 4 times 2 is 8, 5 times 2 is 10. You can have a 6, 8, 10 triangle. You have a triple it, you get 9, 12, 13. All right. We can also have 5, 12, 13 and double it and triple it. And then you can have 8, 15, 17. And you can, of course, double it, triple it, and then the 7, 24, 25. But again, probably the most well-known and the one I've seen on the ACT practice stuff is the 3, 4, 5 triangle. Okay, let's get into it. So example number 1, I'm on the bottom of page 513, and it says we got to find the value of x. Okay, well, the very first thing you want to do is you want to figure out which one's your hypotenuse. It doesn't really matter which one's your A and your B, but the C is the one that counts because that is your hypotenuse. That's the one that's going to be on the other side of the equal sign by itself. To find it, you look at the 90-degree angle, and that little arrow of the box points towards the hypotenuse. So it looks like the x in this particular example is our C, our hypotenuse. Doesn't matter which one's your A and your B for the 17 and the 7, but we are going to plug into the formula. All right, so it looks like they make A 17 and a B a 7, and of course our hypotenuse x is your C. All right, so it looks like we are doing, I guess just 17 squared, and that will be 289, and then 7 squared is 49. Add those together, and you get the 338 that they get. Bring down your x squared. Now, don't forget, if the opposite of adding is to subtract and the opposite of multiplying is dividing, the opposite of squaring is to square root the 338. If you're a brand new teacher, you definitely want to teach your students how to break down a radical for the ACT. And basically, you're doing what's called a factor tree, looking for numbers that multiply to get 338, but one of them needs to be a square rootable number. Let's see. So looking at this, it would be 169 times 2, because 13 times 13 is 169. 169 times 2 is 338, and the square root of 169 is 13. I don't know if all you're familiar with is decimals, then yeah, okay, do that, but please try and teach your students how to break down a radical. All right. Okay, looks like I'm done with that particular one. So I'm going to turn my page, go to example number 2. All right, it says use a Pythagorean triple. All right, to get the value of x. Okay, so let's see. First off, I noticed that, again, here's my right angle. The arrow is pointing towards the hypotenuse, so the 50 is going to be our hypotenuse. All right, so I'm going to scroll up here for my visual people. So as you can see, there's the 50. So it's going to be 14, 48, 50, 50 being the hypotenuse. But it says, notice that 14 and 50 are both multiples of 2, because 14 is 2 times 7, and 50 is 2 times 25. And 7, 24, 25 is the Pythagorean triple. Then the missing length is 2 times 24, which is, of course, 48. And if you are not planning on memorizing these, and to be honest with you, I don't. I've been teaching geometry for a very long time now, over 2 decades. I don't have them memorized. I have this one right here memorized because that's the one you see most often, the 3, 4, 5, and it's double and triple. But I wouldn't know what these are right off the bat. So I usually just do the Pythagorean theorem. 14 squared plus x squared equals 50 squared. And of course, you're going to end up with the 48. All right. Use a Pythagorean triple to find x. We have a 48 and a 20. So we are looking for the hypotenuse. And I want you guys to notice that I don't see a 48 and 20 here at all. There's nothing here. And, you may not have these memorized, but they are, of course, multiples of 2. So, 20 divided by 2 is 10. 48 divided by 2 is 24. So a 10 and 24, there it is right there. 10, 24, and of course it's going to be 26. But let's say that you're just not familiar with those. It's going to be a Pythagorean theorem. 90-degree angle points towards the hypotenuse. And that means your C is going to be X. One more time, you guys, it doesn't matter which one's your A and your B. 48 and 20, doesn't matter which one's your A and your B. It just really matters what the C is. So in our particular problem here, we're going to have 20 squared plus 48 squared, or, it's vice versa. So 20 to the power of 2 plus 48 to the power of 2, that's going to equal C squared. All right, so grab a calculator, put in 20 squared plus 48 squared, and you're going to get 2,704, and that equals C squared. And the opposite of squaring is to square root. And again, one more time, if you are a brand new teacher, you really do want to get in the habit of knowing how to break down a radical. So take the square root of 2,704, and it is just straight up a 52. There's no decimal there at all. So it's just, hey, C is 52. We need to break that one down. All right, there we go. All right, what's coming up next? Example number 3. I'm on page 514 of the workbook at the bottom. Example number 3 says use the Pythagorean theorem. All right, I got a word problem here. Summer camp is building a new zip line lining course. The designer of the course wants the last zip line to start at a platform of 450 meters above the ground and end 775 meters away from the base of the platform. How long must the zip line be? This is your hypotenuse to meet the designer's specifications. Well, we are looking for the side across the 90, which is our hypotenuse. And I think that's what they're talking about in step 1. And we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. All right, so a squared plus b squared equals c squared. I'm assuming that's all they want in that one. Yep. All right, so we're going to do 450 squared. And this is going to be 775 squared. I probably just messed that up. They probably actually wanted me to go ahead and just put in what numbers those are. But grab your calculator, put in 450 squared plus 775 squared, and you're going to get this really big number right there, 803,125. The opposite of squaring is to square root that sucker. So you're going to square root that really big number. And, of course, they give it to us. But if you're not comfortable with that, breaking down of a radical, 896.17 and some change. So there you go. There's example number 3 on page 514. All right, go to the next page. We got our check. All right, looks like it's another word problem. Lincoln High School is installing more wheelchair ramps around the school. One of the new ramps needs, to have a base that is 12 feet long and reaches a height of 1 foot. If the side of the ramp forms a right triangle, how long should the inclined surface of the ramp be? All right, we're looking for the hypotenuse again, you guys. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. In this particular one, we have 12 squared plus 1 squared equals c squared. All right, 12 squared is 144. plus 1 squared. Of course, it's just 1. That gives me 145 equals c squared. The opposite of squaring is to square root a 145. And I'm sitting here racking my brain. Numbers that multiply to get 145. One of them needs to be a square rootable number. So like a perfect square, like 4, because that's 2 times 2, or 9 because it's 3 times 3. 4 times 4 is 16. 5 times 5 is 25. None of these numbers are going to 145. So it looks like it's just going to be square root of 145. Because, yeah, none of those numbers are... Oops. Let me get out of that. There we go. Equals c. All right, so we have the square root of 145, everybody. Now, if you are wanting to know approximately what that is about 12.04-ish. Okay, looks like I'm done with this computer slide anyway. Let me go to the next slide here. Okay, so I am on page 515. In the middle, so they're talking about the converse. Let's see here. Rectangle, 3 sides, shortest is equal to the square length of the longest side. Triangles are right triangles. So it looks like they're determining what, like, the range of what it's going to be, maybe. What's it going to be in between, whether it's acute or obtuse? Yeah, that's what they're doing. So if it's an acute triangle, then, of course, the c squared is going to be less than your a squared plus b squared. And if it's an obtuse, then your c squared is going to be greater than your a squared plus b squared. Okay. What we got here? Example number 4. Looks like they did it for us. All right, determine whether the points A225, B57, and C106 can be the vertices of a triangle. If so, classify the triangle is acute, right, or obtuse. All right, so it's basically just going back to find the distances and figure out if c squared is less than a squared plus b squared, or if c squared is greater than a squared plus b squared. And they do the distance formula for me, and they kind of compare the numbers here. Okay, so, all right, so let me turn to the next page of my workbook. All right, so, all right, we got here. So in step 2, determine whether the measure can form a triangle. So let's see. Looks like the biggest. Okay, we need to look at what the biggest would be. So the biggest is the AC, and that should be your Pythagorean triple the C, the hypotenuse. AC should be the hypotenuse, which is across from angle B, because it's your biggest of the 5 and the 8. So it looks like this should be where the C goes. Okay, so let's see what we got here. They're going to form a right triangle. So let's see. It looks like it's, when you add those together, those two numbers are going to be like, over 10, which is bigger than the C. And when it's greater, it looks like it's going to be, an obtuse? Looks like it's going to be sort of like an obtuse triangle. That's what I'm getting from this. So greater triangle is obtuse. Is that all they're wanting me to do? So, yeah, I guess that's all they want me to do is just, hey, is it obtuse? Yeah, okay. So it's obtuse. It's obtuse. That's all they're wanting. I was kind of unsure where they were going with this. This is not something we usually, talk about on the ACT or even the end of course test. So I was a little, confused. Okay, so the same thing you would do here is you would find the distances of these, and you would see which one is the biggest, and that's going to be your C, and then add the other two to see if it's smaller or bigger. If it's smaller, it's acute. If it's bigger, it is obtuse. Or, hey, you know what I just thought of? Go to GeoGebra. Graph that sucker. If you're a visual person, graph these ordered pairs. Take a good look at what it looks like. I love GeoGebra. It's great for my visual students. So if you're a brand new teacher, do try to get used to that. Something for them to visually see, because you're gonna. Oh wow, I'm done. You're gonna, you know, have a lot of students that are like you, or maybe not like you, who are visual. So if you're wanting to do go that extra mile for your students, learn how to do this in GeoGebra, give them something to look at. You'd be surprised how many students will, on some of these problems on the ACT, they'll give themselves a quick little figure to look at. So yeah, teach them how to do that. That's a good thing to do. All right, you guys, I'm gonna stop right there, and yeah, I'll see you another time. Y'all have a great day.